Good morning, children. We are continuing with the chapter Redox reactions and rate of chemical reactions. In the last class, I told you that when we are discussing about rate of chemical reactions, there are different factors which are favoring the rate of reaction. Rate means the speed of reaction. First is nature of the reactant. Second is concentration. Third is surface area. Fourth one, temperature. And fifth one is catalyst. So the first one we discussed earlier, that is the nature of the reactant. Now we are going to discuss about concentration and rate of the reaction. For that, I am taking two test tubes. Okay, two test tubes. Here also I am taking magnesium metal. Magnesium as the metal. Okay. So, in one test tube, I am taking dilute HCl. Okay. We can name it as test tube A. Yeah, I am taking dilute HCl. In test tube B, I am taking equal volume of concentrated HCl. Okay, in one test tube I have taken dilute HCl and the second one I have taken concentrated HCl. In both of them I am adding this metal magnesium, and then we are going to find out in which test tube the reaction has occurred faster. So before going into that, I want to ask you something. In which among these test tubes the concentration or the amount of HCl will be more? So as you have studied in your 8th standard, you know the difference between concentrated solution and dilute solution. Dilute solution means more amount of water will be there, isn't it? More amount of water, the HCl acid content will be less, water content will be more. Concentrated HCl means the amount of the acid will be more, water content will be less. So, I am adding this magnesium metal here. Magnesium. Here also I am adding magnesium metal to it. So, as I have placed this magnesium metal in the concentrated HCl, the test tube containing concentrated HCl, I could see that the reaction took faster here. Here also reaction occurs, but in this test tube, that is in test tube B, where I have taken concentrated HCl, the reaction has done so faster. Why? Because of the concentration of the solution. It is concentrated HCl here. So how can I write the equation? In both the test tube, the equation will be like this. Mg plus HCl gives MgCl2 plus hydrogen. Okay, in both the test tubes, the reaction is the same. But what I want to tell you is that depending upon the concentration of the reactant, the speed of the reaction becomes faster. Okay, so this is one factor in which concentration is affecting the rate of the reaction. area of solids and rate of reaction. Okay, so when I was teaching you this, I told you that when in olden times, when we were cooking using firewood and all, we don't keep big logs of wood into that fire hole for cooking, isn't it? There will be people to help us. They will be breaking using that axe. They will be cutting this firewood into small pieces, and then using that small pieces, we are using them for cooking. We are burning them for cooking, isn't it? Have you ever thought why we are doing like that? Sometimes when we buy sugar from a shop, from a stationery shop, sometimes the sugar will be so powdered, isn't it? As soon as you put this sugar in a tea, hot tea or hot coffee or in lime juice or something, just one stir, it will be completely dissolved, isn't it? But sometimes when we buy sugar from some shop, we will be getting crystals of sugar, bigger crystals of sugar. You have to stir it, lot of time you have to stand there and stir it continuously for a long time, then only it starts dissolving. So can you just correlate what happened here? Why that powdered sugar dissolved very well and why that crystals of sugar took more time to get dissolved? That is what we are going to discuss today. Surface area of solids and rate of chemical reaction. So for this, I am taking 2 beakers. Okay, 2 beaker. Beaker A and beaker B. In both this beaker, I have taken dilute HCl. Okay, both the beakers are of the same capacity. Okay, here I have taken dilute HCl, same volume of dilute HCl, same capacity beaker. You can say as a 10 ml beaker. Say it is a 10 ml beaker. Here also 10 ml beaker, equal volume of dilute HCl. Now what I am going to do is that I am having a marble piece with me. Marble piece. Okay. So what I will do is that in one beaker, I will be putting that whole marble piece in one beaker. Okay. Big marble pieces. Big marble pieces in one beaker. In another beaker, what I will do is that I will be crushing or powdering that marble piece, and I will putting this powder in the beaker B. So just from using our common sense itself, we can understand in which beaker the reaction will be taking more faster. Of course, the powdered sugar, the powdered marble, isn't it? In the powdered marble, the reaction will be taking much faster. In this one, it takes a lot of time. So what is marble actually? Marble is calcium carbonate, isn't it? CaCO3. So what I am doing is, I have some marble with me. In one beaker, I have put that big pieces of marble pieces. In the other one, I have powdered that marble piece and put in another beaker. In both of them, I have taken the same dilute HCl, same quantity. But as you can observe, what happens is that the powdered marble piece, the one beaker in which powdered marble piece is added, the reaction takes place first. Okay, now what will be the reaction? CaCO3 plus HCl, right? So what will be the reaction? CaCl2 plus CO2 plus H2O. That is the reaction that is taking.
In this video, we're looking at the reaction between calcium carbonate and hydrochloric acid. Each beaker contains 1 molar concentration of hydrochloric acid. Each tray contains 10 grams of calcium carbonate. The difference is this tray contains finely powdered calcium carbonate, this tray contains medium-sized chips of calcium carbonate, and this tray contains one 10-gram piece of calcium carbonate. Okay, we want to examine the reaction rate or the speed of reaction when I add each sample of calcium carbonate to the acid. So when I put in the big piece of calcium carbonate, okay, we can see fizzing, so a chemical reaction is happening. Bubbles of carbon dioxide gas are being produced. This is a slow chemical reaction. If I add in the medium-sized pieces of calcium carbonate, straight away I can hear there's more fizzing. I can see more bubbles of carbon dioxide gas being produced. So this reaction is faster. And for the finely ground sample of calcium carbonate, we can see a very fast reaction. Carbon dioxide being produced very quickly. And now we can hear that the reaction rate is slowing down. It's beginning to stop bubbling.
CaCl2 plus CO2 plus H2. Okay. So what is the theory behind it? So as we powder something, as we crush something, the surface area of that solid increases. Okay, surface area increases. So these acid molecules gets more time, or it has a more affinity towards this powdered particles because the surface area is more, and so this marble powder comes easily in contact with the acid molecules and the reaction takes place faster than the marble, big pieces of marble. Now the fourth factor is temperature and the rate of reaction. So the first factor was nature of the reactant, second one was concentration, third is surface area. Now we are going to the fourth factor, that is temperature and rate of reaction. So for that also we are taking test tubes, 2 test tubes. Okay, in both of them I am taking dilute HCl. Okay, dilute HCl. But this is not the major reactant here. I am taking Na2 S2O3. Okay, what is this called? Sodium thiosulfate. Okay, sodium thiosulfate. Now first what I am going to do is that I am making a solution of sodium thiosulfate, and I am adding first sodium thiosulfate into the beaker. Okay, both the beakers. In both the beakers I am adding, first I am preparing a solution of sodium thiosulfate and I am adding it to both the test tubes, not beaker. And to that I am adding equal volume of dilute HCl. Okay, equal volume of dilute HCl. So here also I am adding dilute HCl. But what I am doing is that only in one test tube or in one boiling tube I am heating it. Okay, I am heating it. Only in one test tube A, I am heating it. The other one I am keeping it as such. So as I started heating it, I could observe that a pale yellow precipitate was formed in test tube A. Very faster. Okay, very faster, very quickly I could observe that a pale yellow precipitate was formed in the test tube where it was heated. After some time I could observe that the same precipitate was formed here also, but it took more time. Why? Because it was not heated here. Okay, so for the molecules to react, Okay, for the molecules to take part in a chemical reaction, these molecules should have a minimum amount of energy. Okay, minimum amount of energy, and that energy is known as threshold energy. Okay, threshold energy. Okay, so when I am heating something, what happens is that when you heat something, what happens? The molecules are getting more kinetic energy. They are attaining the threshold energy very faster and the reaction occurs quickly. So the same thing I am observing here, that is Na2S2SO3, that is the sodium thiosulfate. To it I am adding this hydrochloric acid. And what are the products I am observing? NaCl, H2O, SO2, and one more thing, it is sulfur. Okay, so these are the compounds what I am getting here, that is Na2H2O3 plus HCl gives NaCl plus H2O plus sulfur. So this sulfur causes the formation of pale yellow precipitate. Okay, so when I am increasing the temperature, when I am heating it, what happens? The molecules attain the threshold energy very quickly and they start reacting, and we are getting the final product. So the last one is catalyst and the rate of reaction. So to make you understand about the catalyst, I am writing an equation here. H2O2. Do you know what is this H2O2? It is hydrogen peroxide. Okay, it's not water, it's hydrogen peroxide. When I am heating this hydrogen peroxide, it decomposes or it splits to form H2O plus O2. Okay, this is the reaction when hydrogen peroxide is heated. So I am taking a test tube, putting some hydrogen peroxide into it, heated it. And then I am taking a incense stick, a burning incense stick, and putting it at the mouth of the test tube. Since the gas liberated is oxygen, what happens? Oxygen is a gas which supports burning, isn't it? It supports combustion. So when I am putting this burning incense stick into the mouth of the test tube, the incense stick burns brightly. Okay, so that much thing you understood, no? Now, what I am going to do is that I am going to put some manganese dioxide, MnO2, manganese dioxide, which is a black colored powder, into that test tube. Okay, I am putting that black colored manganese dioxide into that test tube which contains hydrogen peroxide. Again, I am putting this burning incense stick into the mouth of the test tube. Now I could find that the incense stick burned more brightly than before. After adding this manganese dioxide, what I could observe that the reaction between water, the reaction of hydrogen peroxide decomposed to water and oxygen, and this caused the burning of incense stick more brighter. So in this reaction, what happens is that the manganese dioxide, okay, manganese dioxide has acted as a catalyst here, So after the reaction, if you are filtering that solution, okay, if you are filtering the solution, you can observe that the black colored powder you can see in the filter paper. So you must understand that the catalyst I have added is manganese dioxide. It has nothing to do with the chemical reaction. Okay, so catalysts are substances which just speeds up the reaction, alter the reaction, that is speed up the reaction, but does not take part in chemical reaction. Okay, so manganese dioxide is a catalyst. What are catalysts? Catalysts are those substances which increases the speed of the reaction without itself taking part in a reaction. So as you know that this hydrogen peroxide decomposes very quickly. Okay, decomposes very quickly, but so the storage is very difficult, because if you are keeping a bottle of hydrogen peroxide somewhere, it gets easily decomposed. So for that, in order to reduce the decomposition, in laboratories, we will be adding phosphoric acid into it. Okay, we will be adding a little bit of phosphoric acid into it to reduce the decomposition. So here, phosphoric acid is acting as a negative catalyst. Okay, here it is acting as a negative catalyst, whereas here manganese dioxide is a positive catalyst because it is increasing the reaction. Okay, increasing the speed of the reaction, and here it is reducing the decomposition process. So catalyst, what does catalyst means? Catalysts are those substances which is just increasing the speed of the reaction without itself taking part in any chemical reaction. So with this, the chapter redox reactions and rate of chemical reaction is over. Thank you.
Experiment of the effect of catalysts on the rate of chemical reactions. To increase the rate of decomposition of hydrogen peroxide, carry out the following experiment. Measure 25 milliliter of hydrogen peroxide by using a graduated cylinder. Place the compound into a clean conical flask. Add the same volume of hydrogen peroxide into another conical flask. Add the black powder of manganese dioxide gradually to the first flask only. Compare between the reaction in the first flask and the reaction in the second one, related to the rate of reaction. Oxygen gas evolves with an effervescence in the first flask, showing that the rate of reaction in it is faster than the rate of reaction in the second one, due to the effect of manganese dioxide as a catalyst. Summary: manganese dioxide is used as a catalyst to increase the rate of decomposition reaction of hydrogen peroxide into water and oxygen that appears in the form of effervescence.